A dialog is a window, other than the main window of an application, that pops up to either get information from the user or inform the user of some situation. Internally, a dialog has a parent window, which is either a top-level frame window or another dialog window. This is the Show Dialog program that pops up the dialog window. It's a frame with a panel that contains two buttons. The first button pops up the dialog, and the second exits the program. To pop up the dialog, all that is necessary is to create the dialog object. It will pop up and wait for the mouse. This is the non-modal dialog class. It extends the dialog class so it has a frame and a window and can be popped up for display. It also is a component, much like the panel component, so you can insert a layout manager into it and construct a window. A dialog can be anything from a simple statement with an OK button, like the one we have here, to a complex window with dozens of components for data entry. It implements the Action Listener interface so its button can respond to the mouse. Now, the first line of the constructor is a call to super. This is necessary because, if you'll recall, the default call to super automatically inserted by the compiler doesn't pass any parameters, and it's necessary to pass the parent frame to the constructor of the dialog class. The dialog class has a number of constructors. In this program, I chose to use one of them that also accepts a title to be put on the top line of the frame around the dialog. This program uses a border layout manager, has a label at its top, and a push button at its bottom. Just to keep things simple, there is no other formatting, but any of the layout techniques we've been exploring could be used here. Now, there's only one button, and there's only one possible action to be performed, so here is a call to the hide method, which reverses the action of the show method and makes the window disappear. Let me show you what this does. I'm just going to compile everything in the directory, and that way it'll take care of both of these classes. Now, here's the main window. The non-modal button will pop up the dialog, and the OK button will close it. Now, this dialog is non-modal because you can go ahead and do other things while it's up. In fact, you can pop up several of these dialog windows. Each one is independent of the other and independent from the main program, and each one can be closed independently. However, you recall that the frame is the parent window of the dialog, so if the frame no longer exists, the dialogs go away, like this. This lesson is about the more common form of a dialog, a modal dialog. It's called that because when it's up, you can't do anything else. A modal dialog will always stay on top of its parent window and insist on being answered before allowing the user to access anything else in the program. This is an updated version of the Show Dialog program that allows you to start either a modal or non-modal dialog. The only real change from the program in the previous lesson, as you can see right here, is a new button that was added to start the modal dialog. Normally, a modal dialog is popped up to get a response, so here is one of the mechanisms for doing that. The modal dialog is created but does not display itself. In fact, if you wish, you can create a copy of it and use it over and over again. A call to the method getResponse causes the dialog window to appear and wait for input from the user. Once the user has clicked a button, the getResponse method returns with the information. In this example, it's a simple string, but it could be any kind of object containing any kind of information. This is the modal dialog class. In most respects, it's very much like the non-modal dialog class, but there are some crucial differences. It's still necessary to call super to invoke the constructor of the dialog class. Then a call is made to set modal with a true argument, which makes this a modal dialog. Actually, the same thing could have been done by using a different constructor. If you look in the API documentation under dialog, you'll see what I mean. There are several constructors that allow you to include the modal setting. The bottom portion of the window is a panel containing 4 buttons. These buttons are labeled with the sort of selections you'll find in a dialog window. All of this is normal, and all of it's stuff you understand, but let me show you a new trick that's in here. Notice that the constructor builds the window and packs it, but does not call show. The reason for this is that the show method is called later. Whenever a call is made to getResponse, a call is made to show to make the dialog appear. At that point, the user is prevented from doing anything except pressing one of the dialog buttons in this window. And there's something special about the show method that is different in a modal dialog. The show method blocks. That is, it does not return until the window has been closed. You see, that's part of why this thing is modal. The rest of your program can't do a thing unless you started it running in another thread or something. The thread of the program is halted right here. When it does finally close, this method returns the response to the caller. This is the method called whenever a button is pressed. In this example, the action command string from the button is stored in the string variable named response. Next, a call is made to hide, which closes the window by undoing the work of show. Not only does this cause show to return, but this method returns the copy of the response string that it got from the button back to the original caller. Before I show you how this program works, let me tell you another common approach to this. You know the frame is passed in to act as the parent of this window. Well, if the frame is also an action listener, it can be added to the button's action listener lists and be called directly whenever a button is clicked. Anyway, here's how this program works. Now, this dialog prevents access to the parent window. Not only that, but the two of them are connected together. You can access other programs, but the only thing you can do with this program is move this dialog around and make a dialog selection. The selection closes the window, allows the method to return, and the program then prints out the name of the button you selected. This lesson describes a sort of general-purpose dialog that you can use to pose a question of or send a message to your user. When you create the dialog object, you must specify the text of the message and the selection buttons that are to be made available. This is the program that uses the dialog to prompt from the user. It's about the same as the program we've been using to demonstrate the fundamentals of dialogues. Oh, by the way, the windows we've been dealing with up until now always appeared in the upper left-hand corner of the screen. You could actually have a window appear anywhere you want. All you have to do is say so in a call to set location. Just like all Java graphics, this location specifies the position in the window of the upper left-hand corner. The main window has 3 buttons. Each one of these buttons will cause a dialog to appear, and the program waits for a response. The action performed method is the one that's called whenever any one of the three buttons is pressed. If this statement is true, the try button has been selected. This is the text of the message that is to be displayed in the dialog window. It's an array of string objects, so the text message can be as many lines as you would like or as you would need. It's most common to have just one line, but sometimes it's necessary for 2, 3, or even more. Another array of string objects specifies the buttons to be displayed on the dialog. This example has just one. The only thing the user is going to be able to do is OK the message. Just like we did earlier with the modal dialog, this dialog is constructed and a call is made to get response to display the window and retrieve the labeled text of the button the user selected. In this case, there's only one button, so we already know what the return string is going to be, so we just ignore it. The information here is needed to construct the dialog and is passed to the constructor as parameters. The reference to this window is passed because the dialog does need a parent. Next, a string will be used on the title line of the dialog window. The text of the message and the array of button labels are also passed to the constructor. The selection of the favorite button will cause this block of text to execute and build an ask dialog with several buttons. Whatever response is returned from the dialog is used as the title on this window. And this is for the exit button. This is an exit button with the famous "Are you sure?" message. If the answer is yes, the window is closed. Most of the code in the dialog itself will be familiar to you. It's almost all the same stuff you've seen before. It's just being used in a different way. The Ask Dialog class extends the Dialog class and implements the Action Listener interface. Now, this is the only constructor of this class. As we saw before, it requires a parent frame, the title string, and two string arrays, one for the text and one for the button labels. The call to the constructor of the dialog class includes the parent window, the title to go at the top of the dialog window, and the flag setting that will make this a modal dialog. This sort of pop-up dialog with a simple push-button answer is almost always a modal dialog. Doing this sort of thing in a non-modal dialog can cause the dialog to get lost behind the other windows and forgotten about. Anyway, this dialog won't just appear in the upper left-hand corner either. It's positioned in relation to the parent window. The call to get location on screen returns a point object that contains the X and Y position of the upper left-hand corner of the parent window. The values in the point object are adjusted so the upper left-hand corner of the dialog appears 40 pixels to the left and 60 pixels below the upper left-hand corner of the parent window. Now, you'll probably want to change this, but it seems about right to me, but not having any taste, how would I know? This new position is assigned to the dialog with a call to set location. This dialog is based on a border layout manager with a text panel inserted at the top and a button panel inserted at the bottom. This method accepts an array of string objects containing the text and constructs a panel that holds labels displaying them. A grid layout is constructed that has only one column but has one row for each line of text in the array. Now, this loop executes once for each line of text. In the loop, a label containing the text is constructed and added to the panel. This method takes the array of button label strings and creates a panel containing the buttons. For each member of the array, a button is created, has this object inserted as its action listener, and is added to the panel. Now, these last two methods are the same as they were in the dialogs we looked at earlier. A call is made to the getResponse method, which executes a call to the show method, and that pops up the dialog, and then it blocks and waits. When a button is selected, that causes a call to actionPerformed, which records the name of the button as the response, and then calls hide. The hide method shuts the window and causes the show method to return, which allows the getResponse method to return with a response string. The window first appears in the middle of the screen instead of in the corner. The Try button pops up a dialog just underneath the button, and the OK button closes it. Notice that no matter where the main window is located, the dialog pops up near it. Notice that the selection that's made always becomes the window title. Of course, this window is a bit small for some of them. This lesson is an introduction to the menu bar on the frame. The frame class implements the menu container interface, which means it has all the methods you need to add a menu bar across the top of the window of a frame. The only thing new here is the mechanics of the menu itself. Fundamentally, it's a collection of push buttons with callbacks. Here at the top of the class, we have the declaration of a couple of menu items that we will need to reach from more than one method, and there's also a reference to a file handler class. I'll show you what all these are for in just a minute. This code creates the new menu bar. This is the bar that goes across the top of the window and holds all the menu buttons. This menu bar is going to contain two pull-down menus. The two are inserted into the menu bar with calls to add. This call inserts the menu bar itself into the frame. Just as we had methods earlier that produce panels for insertion into containers, this method produces a single pull-down menu for insertion into the menu bar. It isn't necessary to do it this way. You can do the whole thing in one large block of code, but separating things out this way makes it easier to find and work with. In larger programs where the menu is going to be extensive, you might even consider a separate class that does nothing but create the menu. This is the pull-down menu itself. As tradition dictates, the first menu on the menu bar is named File. The rest of this method does nothing but construct individual items that go onto the pull-down menu. These three lines of code create an open menu selection. A menu item object is a special button that goes into a menu, but it is a button, as you can see, because it uses a call to add action listener to set up a callback. In this example, the action listener object is another class named File Handler. Finally, the add method of the file menu is called to insert the item into the menu. We now have a pull-down menu with one button. Now this is where the second selection is added to the menu. It's the same as the first, except this one has a shortcut key added. The key event named VKS, or Virtual Key S, is Control S. All of the keys are defined as static constants in the class keyEvent. Anyway, this menu button is assigned the same action listener as the previous one was, and then it's added to the menu. The Save Add button is assigned the same shortcut key as the previous button, but this one has a second parameter passed to menu shortcut to indicate that the Shift key must be held down. That means the shortcut for this menu entry is Control-Shift-S. Anyway, it's also assigned its action listener and added to the menu. This call to set action command changes the action command that's passed to the action listener. It doesn't change the string displayed on the menu button. It only affects the string sent to the callback. Things other than buttons can be added to a menu. For example, you can add secondary menus and check buttons, or you can insert a simple little divider known as a separator. These are often used to group similar selection items together on a menu, or in this case, to set off the last entry in the menu to indicate that it's a bit special. The last button is added to the menu. The action listener for this button is not the file handler class like the other buttons. It's this object, which is also an action listener. It's common in a menu to have several action listeners and spread the menu responses around among them. At the end of the method, the file menu containing all of its buttons is returned to the caller. This method creates another menu in much the same way as the file menu was created. A menu object is created. It will be populated with buttons and returned to the caller. These two buttons, labeled Disabled and Enable, are added as the first two buttons on the menu. They're assigned to this object as the action listener. Now, these two buttons are the magic words, and they're also added to this menu. And finally, the fully constructed menu is returned to the caller. Every button that has this method listed as its callback has its action command listed on the screen. The exit button does just what you would expect it to do. It exits the program. The Enable menu button executes this block of 2 lines of code, which sets the 2 menu items to be enabled. You may recall that these 2 menu items were declared outside the methods at the top of the class, and this is why we needed to be able to reach them from in here to turn them on. Every menu button starts out enabled, but these 2 buttons could be disabled if this button had been selected and the 2 lines of code executed. You can use Enable and Disable to turn these 2 buttons on and off. Here is the other action listener. This is just a dummy class that doesn't do anything. It doesn't even have a constructor. It does nothing other than display the word file handler followed by the action command from the button. Here are all the buttons defined in the program, and a separator just above the exit button. Also notice that the Save and Save As buttons are annotated with the keyboard shortcuts that were assigned to them. As you can see, the magic words are working. If they are disabled, they can be enabled again, and they work again. And that's a general introduction to menus.